Today we are going to discuss some of the problems on Fourier transform. First problem, find the Fourier transform of x of t is equal to e into minus a of mod t, where a is greater than 0, and draw its spectrum. So we know that x of j omega is equal to integration minus infinity to infinity x of t into e power minus j omega t into dt, or x of j omega is equal to integration minus infinity to infinity e power minus a into mod t into e power minus j omega t into dt. Or I can write it as integration minus infinity to 0 e power at into e power minus j omega t into dt plus integration 0 to infinity e power minus at e power minus j omega t into dt, which is equal to integration minus infinity to 0 e power a minus j omega into t into dt plus integration 0 to infinity e power minus a plus j omega into t into dt, which is equal to 1 divided by a minus j omega plus 1 divided by a plus j omega. Then x of j omega is equal to 2a divided by a square plus omega square. Since x of t is even symmetric, then x of j omega is purely real. So we can draw the spectrum as x of j omega so 0, this a and this is minus a, one by a amplitude, and this is 2 by a. Next problem, determine the Fourier transform of the unit impulse function, that is x of t is equal to delta of t, and draw its spectrum. We know that x of j omega is equal to minus infinity to infinity x of t into e power minus j omega t into dt, or x of j omega is equal to integration minus infinity to infinity delta of t into e power minus j omega t into dt, which is equal to e power minus j omega t at t is equal to 0. So x of j omega is equal to 1. Then the spectrum will be this is 0, this is 1, x of j omega. Next problem, find the Fourier transform of unit step function. That is x of t is equal to u of t. So we can write sine function is equal to 2 into u of t minus 1, or u of t is equal to half plus half sine of t. Then taking Fourier transform on both sides, we get Fourier transform of u of t is equal to half into 2 pi delta of omega plus half into 2 divided by j omega, which is equal to pi into delta of omega plus 1 divided by j omega. For the rectangular pulse shown, find the Fourier transform. So this is the pulse given, x of t 0, minus t and plus t, this is 1. So from the given pulse we can write x of t is equal to 1, where t varies between minus t to plus t, and 0 otherwise. Then x of j omega is equal to minus infinity to infinity x of t into e power minus j omega t into dt, which is equal to integration minus t to t 1 into e power minus j omega t into dt, which is equal to e power minus j omega t divided by minus j omega, varies from minus t to plus t, which is equal to 1 divided by minus j omega into e power minus j omega t minus e power j omega t, or x of j omega is equal to 2 sine omega t divided by omega. Find the Fourier transform of the signal x of t is equal to t into e power minus 2t into u of t. obtain the expression for the magnitude and phase spectra. We know that x of j omega is equal to minus infinity to infinity x of t into e power minus j omega t into dt, which is equal to 0 to infinity t into e power minus 2t into e power minus j omega t into dt. Here we have to take it from 0 because the function is unit step function. U of t starts from 0. So integration starts from 0 to infinity t into e power minus 2t into e power minus j omega t into dt, which is equal to integration 0 to infinity t into e power minus of 2 plus j omega into t into dt, or x of j omega is equal to 1 divided by 2 plus j omega whole square, which is equal to 1 divided by 4 minus omega square plus j 4 omega. Therefore, magnitude of x of j omega is equal to 1 divided by root of 4 minus omega square whole square plus 4 omega square, and angle x of j omega is equal to minus tan inverse of 4 omega divided by 4 minus omega square. For the signal x of t shown below, find the Fourier transform. This is the signal given. This is 2 x of t 0, 2 and minus 2 with amplitude 1 and minus 1. So from the given figure, we can write x of t is equal to 1 when t is between minus 2 and 0, and minus 1 0 less than t less than 2 and 0 otherwise. We know that x of j omega is equal to integration minus infinity to infinity x of t into e power minus j omega t into dt, which is equal to integration minus 2 to 0 1 into e power minus j omega t into dt plus integration 0 to 2 minus 1 into e power minus j omega t into dt, which is equal to integration minus 2 to 0 e power minus j omega t into dt minus integration 0 to t 0 to 2 e power minus j omega t into dt. So after simplification, we get x of j omega is equal to 2 into cos of 2 omega minus 1 divided by j omega. Determine the time domain signal corresponding to the following Fourier transform. X of j omega is equal to e power minus 2 omega into u of omega. And we know that x of t is equal to 1 divided by 2 pi integration minus infinity to infinity x of j omega into e power j omega t into d omega. Therefore, x of t is equal to 1 divided by 2 pi integration 0 to infinity e power minus 2 omega into e power j omega t into d omega, which is equal to 1 divided by 2 pi integration 0 to infinity e power minus 2 minus j into t into omega into d omega, or x of t is equal to 1 divided by 2 pi into 2 minus jt. Next problem, compute the Fourier transform for the signal x of t as shown. The given signal is 0, 1, 2, 3, x of t is 1 and 2. It's minus 1, minus 2. This is 1 and here it is minus 1. So from above figure, I can write x of t is equal to 1 from minus 1 to 0. And x of t is equal to 2 from 0 to 1. And minus 1 between 1 and 3. And 0 otherwise. And we know that x of j omega is equal to integration minus infinity to infinity x of t into e power minus j omega t into dt, which is equal to first integration minus 1 to 0, 1 into e power minus j omega t into dt plus integration 0 to 1, 2 into e power minus j omega t into dt minus integration 1 to 3. 1 into e power minus j omega t into dt, or x of j omega is equal to 1 divided by j omega into 1 plus e power j omega minus 3 into e power minus j omega plus e into minus j 3 omega. Using partial fraction, determine inverse Fourier transform of x of j omega is equal to 5j omega plus 12 divided by j omega whole square plus 5 into j omega plus x, and it is given x of j omega is equal to 5j omega plus 12 divided by j omega whole square plus 5j omega plus 6, which is equal to 5j omega plus 12 divided by j omega plus 3 into j omega plus 2. By partial fraction expansion, we get x of j omega is equal to 3 divided by j omega plus 3 plus 2 divided by j omega plus 2. Then taking inverse Fourier transform, we get x of t is equal to 3 into e power minus 3t into u of t plus 2 into e power minus 2t into u of t. Therefore, x of t is equal to 3 into e power minus 3t plus 2 into e power minus 2t into u of t.